Hello everyone. In the previous session we have seen what is Dijkstra's algorithm, Bell-Manford algorithm and why we use it. We use those two algorithms to calculate the shortest distance between a given source node to all the corresponding vertices, right? And in this session we are going to talk about a concept called as minimum spanning tree, which is also known as MST. And based on the concept of MST, we have two algorithms that are Prim's algorithm and Kruskal algorithm, and these two are very, like you can say, famous and at the same time very important algorithms when it comes to graph theory, right? So first of all, let us begin with what is a MST, or what is a minimum spanning tree. So we have studied trees, right? We have studied binary trees, binary search trees, AVL trees and tries. And if you observe the structure of trees, if you observe the structure of binary trees, binary search trees or AVL trees, you might have observed that in those diagrams we don't have any cycles. We haven't seen a condition where there is a formation of cycle in the given structure. So in trees there is no concept as cycle formation, there is no concept as loop formation. We cannot have any loops, any cycles in a given you can say tree, whatever it might be, whether it might be trie, binary tree, BST, AVL, whatever it might be. In trees we don't have any cycle, but in graph we have cycle formation, and we have different algorithms to find the cycle formation, whether the cycle exists or not in my graph. So the basic meaning of a spanning tree in general is that you have a given graph. Let's say I have a graph. This is the graph, whatever the graph it might be, I have a graph. Now my goal, I'm saying this in terms of layman's, right? The basic definition of spanning tree is that you have a graph, and this graph, whatever the graph you are having, if you want to convert it into a tree, then it is known as basically a spanning tree. So if you want to extract the tree out of it, whatever the tree that can be formed out of this graph, right? Whatever the tree that can be extracted from this given graph, then the structure, then the tree structure, whatever the tree structure you will get without any loops, without any cycles, that structure is known as spanning tree. And if the extracted, whatever the tree you have extracted, if the edges value is minimum, whatever the edges you have chosen, those values are minimum, the edges values are minimum, then that particular structure is known as minimum spanning tree, which is nothing but MST. So here if you go with formal definition, a minimum spanning tree or minimum weighted spanning tree is a subset of the edges of a connected graph. Here you can see that this is a connected graph with having some edges in between here. Now what we are supposed to do here is that we need to convert this graph into a tree without any cycles, and the edges which are involved in this should have minimum length. And if I can able to create a graph, if I can able to extract a structure out of the given graph, whatever the graph might be, if I can able to extract a structure which is similar to tree, it doesn't have to be a binary tree, it can be a tree with a number of nodes. But the main motive here is that if we can able to remove the cycles in such a way that whatever the edges connected, here you can see that whatever the edges connected with all the other nodes should be minimum. If I can able to create this condition, if I can able to create this sort of structure, then that structure is said to be a minimum spanning tree, or you can say MST structure. I hope you are very clear, right? The basic definition of MST is that we have a graph, and in the graph we have cycles. The main motive of us is to remove cycles, and you can say that in basic terms, from this graph you are extracting a tree, whatever a tree might be. It doesn't have to be a binary tree, a tree with n number of nodes. But the main motive is that from this graph we need to remove cycles, and the edges should be connected in such a way that the weight of each and every edge should be minimum. If I can able to create this condition, then it is said to be a minimum spanning tree. Right? I hope you are very clear. Now you can see that in the given structure I am having loops. Here I am having loops, loop here, and loop here, and this. Now if I manually go with, okay, let me remove this edge and check whether I am creating a minimum spanning tree or not. Okay, let me remove this edge between AB or BC or BE. If I go with manual things, let's say my graph is huge, then I cannot, right? There can be n number of possibilities, n number of combinations and permutations that can be extracted from a single structure. So this structure can have n number of forms, and among this n number of forms I need to choose a form which is MST, in which all the edges should be minimum. So it cannot look complex, it cannot sound complex, right? So in order to extract MST out of a given graph, we use two algorithms. First one is Prim's algorithm and the second one is Kruskal's algorithm. So let us talk about Prim's algorithm. So in Prim's algorithm, we use a concept of MST set. I will talk about what is a MST set in just a while. So here you can see that this is the graph I am having. Okay, and one more thing is that here you can see that edge weighted undirected graph. Here MST can be formed for undirected graph. For directed graph, we cannot break graph into different pieces such that the cycle can be removed. I think we cannot do that. But MST is for undirected graph. You need to remember weighted and undirected graph. If we are having two conditions, then there is a possibility that MST can be extracted, MST can be derived from the given graph. There is a probability there. Okay. So here let us coming back to our Prim's algorithm. So I am having a undirected weighted graph. Okay, and my goal of Prim's algorithm is that from this given graph I need to extract my minimum spanning tree. So here you can see that I can create a spanning tree. Let us consider what are the different spanning trees that can be possible. Here 0 is a node, and I can connect 0 with 1, and I can connect 0 with 2, and I can connect 0 with 2. Okay, here this is 3 actually. Yeah, now you can see that I cannot connect now 0 with 2. If I connect with 0 with 2, then it will form a loop, and in spanning tree the only condition is that we need to extract, or you can say remove edges in such a way that there will be no cycle formation. So if I connect 3 with 0, it will form a loop. If I connect 3 with 2, it will form a loop. So I cannot add this edges. For this structure, I cannot add the edges of 3 to 0 and 3 to 2. So if I add this, then it will create a cycle, right? So let us calculate the cost here, because my MST, my spanning tree is said to be a MST only when all the edges should be minimum. Okay, so here the edge value is 10, 40 and 50. So the total cost of all the edges will be 10 plus 15 plus 40. So this will give me 25 plus 40. So this will give me 65. Now from this diagram I can also extract another structure like this. 0 is connected to 1, 1 is connected to 2, and 2 is connected to 3. Now I cannot connect 1 with 2 because it will form a cycle. I cannot connect 2 with 3. It will form a cycle. Now check the edges value. Here 10, 30 and 15. So from this, if I calculate the cost out of it, then cost will be 10 plus 30 plus 15. So this will give me 40 plus 15, 55. So this will give me 55. So here this is giving me 65, and the second structure is giving me total cost as 55. Which one is minimum? The second structure is minimum. So the second structure will become my minimum spanning tree. The first structure is a spanning tree spanning tree, but it is not a minimum spanning tree because the edges involved in the first structure is not minimum, whereas in the second structure the edges are minimum. The edges length, the edges value is minimum. If it is minimum, then and only I can say that the given structure is a minimum spanning tree, else it will not be a minimum spanning tree. Okay, I hope you got the logic. So here what we are gonna do is that, let me remove all the ink here. So here I will create a MST set. So here I will create two sets, and these are imaginary sets. In order to understand the working of our algorithm, we are imagining this. Okay, so here I will create a MST set, and I will create another set called as non-MST set. Non-MST set, and I will create a visited array in order to keep track whether I have visited my particular node in my graph. So I will create visited array, and here I will store my nodes 0, 1, 2, 3, and initially all the nodes are assigned with false. Okay, are assigned with false. Now what I will do is that I will take all the nodes and I will put all the nodes in my non-MST set. So I will add all the nodes here in my non-MST set 0, 1, 2, 3. Now after adding all the sets, all the nodes in the non-MST set, I will take any one of the node. For example, I am taking 0. So I will take 0, I will remove from non-MST set and I will add it into my MST set. So I will add 0 in my MST set. I will take this and I will add it here. Now I will remove from non-MST set, I will remove 0 and I will make visited of 0 as true. So here I will store true here. Okay, now if you observe the sets, in MST set I have 0, in non-MST set I have 1, 2, 3. Now what I will try to do is that I will try to make a link from whatever the nodes I am having. In MST set I am having 0, right? So from 0, whether there is a connection to any one of the nodes in my non-MST set. So from MST, whatever the nodes I am having, I will take that node and I will check in my non-MST set whether these two are having any link. And if they are having link, then what is the edge value? I will compare it. So I will try to make a connection from MST set to non-MST set. Here you can see that I am having, if I talk about this current structure, 0 is having connection with 1, 0 is having connection with 2, and 0 is having connection with 3. Now let us observe the edge values here. So I will observe the edge values. Here you can see that the edge value is 10. The edge value is 0 to 2 is 15, and the edge value between 0 to 3 is 30. Now what we will do is that we will choose a node which is having the least edge value. So I will take among this, which one is minimum? Among this one is minimum. So I will take 1 and I will add that node into my MST set and I will remove from my non-MST set, and I will make the visited of 1 as true. So I will make visited of 1 as true. Okay, now here you can see that in my MST set I have 0 and 1, in my non-MST set I have 2 and 3. Now I will try to consider the connections that can be possible. So here if I go with the current diagram, I am having connection 0 is having connection with 2, 0 is having connection with 3, and 1 is having connection with only 3. 1 is not having any connection with 2 node. Here you can see that from the diagram I am extracting the connections. Okay, so here 0 is having connection with 2 and the cost is 15, and 0 is having connection with 3 and the cost is 30, right? And 1 is having the connection with 3 but the cost here is 15. So among this, which one is minimum? The first one is minimum. So I will take 2 and I will add 2 into my non-MST set. So I will add here 2 and remove from here, and I will make visited of 2 as true. Okay, now I will see the current diagram. So my current diagram looks like this. In MST set I am having 0, 1, 2. 2, and in non-MST set I am having only one node, which is 3. So I will try to make connections with the existing non-MST elements with the existing non-MST elements. So here 0 is having connection with 3, okay, and the cost of it is 30, and 2 is having connection with 3 and the cost of it is 50, and 1 is having connection with 3 and the cost of that is 40. Now my question is, which one is minimum? The minimum is this one, okay. So I will add 3 into my MST set and I will remove my non-MST set. Now my non-MST set will become empty. This is my non-MST set, and my MST set will have 1, 2, 3 and 0 node. This is my MST set. Now what are the connections we have established here? The connections which we have established is 0 with 1, 0 with 2 and 0 with 3, which is, if I draw the diagram, then 0 is connected with 1 and 0 is connected with 2 and 0 is connected with 3, and the edge values are minimum. At each and every iteration I have only chosen the elements which are minimum, okay. So here the value is 10, the value is 15 and the value is 30. So the total cost of this MST will become 10 plus 15 plus 30. This will give me what? 25 plus 30. This will give me 55 as my output, right? And this structure is my minimum spanning tree structure, and this is the working of Prim's algorithm. I hope you got the working of Prim's algorithm, the overall, at least the basic premises of Prim's algorithm. Now let us talk about the approach of Prim's algorithm. So let me remove the ink here. How we gonna code? We have understood the algorithm, we have understood the approach. Now let us talk about how we gonna code this thing. So what I will do is that, first of all, I'm gonna use a concept of priority queue, because if you observe, I have different cases. I have different connections. 0 is connected with 1, 0 is connected with 2, 0 is connected with 3. But irrespective of the connections, I'm only taking elements, I'm only taking the pairs. Here 0 and 1 is a pair, 1 and 2 is a pair, 3 and 1 is a pair. So I am considering a pair which is minimum. And whenever you think of minimum, you will think two things. One is greedy and the second one is priority queue. So here I am gonna use priority queue, and in the priority queue I will store my vertex and my cost, and here I will try to store the pair which is having minimum cost, right? So I will only store elements which is having minimum cost, okay. So in my priority queue I will create a priority queue and I will add elements. I will add pairs of elements. Here you can see that 0 and 1 is a pair, and I will only add these two elements which is having the least cost, okay. Now after that I will create my visited array as usual, and I will run a loop while my PQ is not empty. PQ is not empty, and in that what I will do is that I will I will store the current value pq.remove, and if current is not yet visited, then I will visit it, and after visiting it I will call for the neighbors, and in the neighbors I will add the neighbors in my priority queue based on the priority, based on the pairing priority, right? Like this I will do, and this will give me my Prim's algorithm. This will give me my minimum spanning tree structure, and from this I will calculate the cost. Here we have extracted that the cost for this structure, the MST cost will be 55. So whatever the code I am creating, that should give me answer 55. I hope you have understood the approach, the overall concept of Prim's algorithm, and how we gonna implement the code of Prim's algorithm. Now let us code this thing. So in the program, first of all I have imported my import java.util.star and my universal classroom, and in that I have created my edge class. And now in the program creates function, I have created a graph which is similar to this. I have whatever the example I have dry run, I have created the same graph in my program, okay. Now what I'm gonna do is that, first of all let me create my function public static void prims. I'm giving my function name as prims, and in this I will pass my graph. array list of my H graph. Here let me give graph here, graph list, not graph. So graph graph. Okay, I am passing my graph. Now in this, what I will do is that first of all I will create my visited. So visited is equals to new boolean, and the length of this will be graph.length. Graph.length. Okay, now what I will do is that the second step will be create your priority queue. So here I will create my priority queue, and here I am storing pairs. So to store pairs, let me define my class, public class, static public static class pair, and pair, and here I will perform my sorting internally in my priority queue. Sorting will happen based on the weight of that particular edge. So here I need to implement my comparator interface. So if you are not getting some concepts here, we have already talked about what is comparable interface, comparators, collections in greedy chapter. So I recommend you guys to just give a little little bit revision to greedy algorithms. Okay, so here what I will do is that I will write implements comparable interface, comparable of my pair, and here I will write my int v, which is my node, and int cost of that node, cost of that edge, and let me create a constructor public pair, and it is showing some kind of error. Comparator, comparable, here int to give comparable interface. So comparable pair. Okay, now here let me give pair int v comma int cost. Okay, now here I will initialize the value int dot v is equals to v, this dot cost is equals to cost. Okay, now I will write my function, comparable function. So here I need to override, and here I will write public int type function, because here we are returning the integer value based on the path, the weight which is least. I will return the least weight value. So here I will write my pair compare to function, compare to, and in this I will pass my pair p2. Here I will return this dot cost minus p2 dot cost. So this will give me priority in ascending order. This will sort elements in ascending order. Now if I want elements in descending order, then I will write p2 minus cost minus this cost, p2 dot cost minus this dot cost. This will give me priority in descending order. If I want priority in ascending order, then I will write this line. Okay, I hope you got here. Now in the function, in our function Prism function, I will create my priority queue pair pq is equals to new priority queue. Now here first of all I will add my initial element, and the initial element is 0, and the cost of that initially is 0. Okay, now after that I will create a function int final cost. Int final cost is equals to, initially it is 0. Now I will run a loop while my pq dot is empty. If this is not empty, then I will store pair current pair is equals to pq dot remove, and if the current element, whatever the current element I am having, current dot v, that particular element is not yet visited, then first of all I will visit that element. So curr dot v is equals to true. I will make this as true. Now I will add its cost, final cost plus is equals to my curr dot cost, whatever the cost it is having, take that cost. Okay, and I will add that into my final cost. Okay, so let me save this, and here after calculating this, I will call for my all the neighbors. So I will write for int I is equals to 0 and I should be less than graph dot length, graph of current dot v dot size. Here let me give dot size, and here I need to remove this dot here. Okay, now I plus plus. What I will do is that I will calculate all the edges. So h e is equals to graph of my curr dot v dot get ith element, right? So I'm getting the ith element, which is my neighbor element. Now what I will do is that I will add pq dot add. I will add my new pair. Here I will pass my e dot destination, and the cost will become e dot weight. Whatever the weight it is having along with it, that will become my cost of that particular pair, right? Now finally after this I will print system dot out dot print final cost of MST is, and finally I will print my final cost. Now in the main program what I will do is that I will call my Prim's algorithm and I will pass my graph. So let me save this. So let me summarize what I am doing. First of all, I have created in the Prim's algorithm, in the Prim's function, I have declared my visited array, and this visited will keep track whether a particular element is visited or not. Now after that I have created my priority queue, and I have added new pair into my priority queue. Okay, I have added the source node and its initial cost is 0. Now I have, in order to keep track what is the total cost of my MST, I have created a variable int final cost is equals to 0. Now I am running a loop. In the loop I am calculating whether a particular node is visited or not. If it is not visited, then I am performing these two steps inside that, and after that I am calculating for all the neighbors its cost, its connected or related cost. Okay, and finally I am printing its total cost of that particular MST. I hope you got the thing. Now if I run this, then I will get the output, whatever the cost interlinked with this graph, I will get that output. So let me save and run this. So it is showing some kind of error. Line 37, this dot v is equals to v. Okay, now let me save and again run this. Now if I run this, I should get the output as final cost of MST is 55. Like this I will calculate for this given structure, I will calculate Prim's algorithm. So this is my Prim's algorithm. I hope you got the overall working and the logic of Prim's algorithm. Now let us talk about Kruskal's algorithm. The second algorithm we use in order to calculate MST for a given graph is Kruskal's algorithm, and Kruskal's algorithm is based on greedy approach, right? And it is relatively, you can say, easier, simpler than Prim's algorithm, because greedy is involved in it. We are not doing anything, we will not do anything here, but we will use the greedy approach. And the approach of this algorithm is that, first of all, this algorithm says that whatever the nodes you are having, whatever the edges you are having, sort those edges first, right? Take those edges, sort them, and after sorting, take the minimum value, take the minimum cost edge. Whatever the cost you are having, take that minimum cost, and you should make sure in this process you should not take elements, you should not take edges which can form a cycle, because if it is forming a cycle, then it is not a spanning tree itself, right? So we should not consider edges which can form cycle. And along with this, whatever the nodes which are not forming and are minimum, include that in your answer, and finally you will get your answer. You will get the total cost of your MST, so include it in your answer, right? Finally you will get your answer. These are the two steps of Kruskal's algorithm. So let us understand how Kruskal algorithms work. So here this is the graph I am having, and I have sorted the nodes according to their weights. So here the weight between 0 and 1 is 10, and similarly 0 and 10 is 15. Like this I have sorted the elements. Now what I will do is that I will take the nodes from the ascending order. So this is in ascending order, right? So I will take 0 and its corresponding destination 1, and I will add these two and I will check whether they are forming a cycle. Here you can see that there are only two nodes and they will not form a cycle. So if they are not forming cycle, then I will add them. I will connect the edge between these two nodes. Okay, now after that I will go here. 0 is connected to 2, so this is my 2 node, and I will connect these two and I will check whether the given structure, whatever the structure I am having, whether they are forming a cycle. No, they are not forming a cycle. So if they are not forming a cycle, then it is good. I can add it, right? Now I will come here and I will check 0 is connecting with 3. So I will try to connect 0 with 3 and I will check whether they are forming a cycle. No, they are not forming a cycle. If they are not forming a cycle, then it is okay to add that node into our MST. So I will add that node into my MST. Now I will come to the next item. 1 is connected with 3. 1 here, actually this is 3 and this is 2. So 1 is connected with 3. So if I connect 1 with 3, then what will happen? It will create a cycle. And if it is creating a cycle, then I will not consider that two elements, that two nodes as a connection. So I will not connect them. So I will remove this. I will not consider it in my MST. Now after that I will come here and 2 is connecting with 3. 2 is connecting with 3. Again it is forming a cycle. And the same, if it is forming a cycle, then I will not consider those two connection, that edge into my MST. So I will also reject this. Now my MST which I got from this is 0. 0 is connected 1, 0 is connected with 2 and 0 is connected with 3. And what is the cost of this MST? The cost is minimum because I have chosen the elements which is minimum first. After that I have chosen the elements which is having highest value at last. I hope you got the logic here. So 10, 15 and 30. So the cost of this MST will become 10 plus 15 plus 30. And this will be around 55, right? Like this I will calculate MST. This is the approach of greedy algorithm for Kruskal algorithm. Okay, now let us talk about how we gonna code this. So let me remove all this here. Let me remove all these things here. So talking about the approach, what I will do is that, talking about the approach, first of all I will create a array list of edge type. Up to now we have studied how we can create a graph using adjacency list. Now I am gonna create a graph using edge list, and in that list I will sort all the elements of my edge list using collection framework. I know collection framework. In array list I have studied how we can sort array list, right? So I will write here collections and I will pass my dot sort and I will pass my array list and I will give the corresponding parameters on what basis my sorting will happen in ascending or descending order. I will give that in my program. Okay, now after sorting I will run a loop for I is equals to 0 to v minus 1, and in this what is my step? I need to, whenever I am connecting two nodes, let's say this is a node and this is another node, and whenever I am creating a connection I should make sure whether they are creating a cycle or not. If they are not creating a cycle, then and only I will add them. If they are creating a cycle, then I will not add them in my MST. Okay, so I need to check whether they are creating a cycle or not, and to check whether they are creating a cycle or not, we use an approach called as union disjoint approach or union find approach. Union find approach. In the code I will show you, I will talk about what is union and find, but let me tell you in general terms that union will combine two elements, right? Union will combine two elements. Let's say I am having node A and node B. Union is used to include node A to B, so it will combine these two nodes. Okay, and find is used to find the parent between any two nodes. If A and B, let's say A and B. So whenever I am passing two nodes, a find function will return the parent of that particular node. Here it will check. If I am passing to find function, if I am passing A, then it will return me parent of A. To find function, if I am passing B, then it will return the parent of B. Okay, now the condition of cycle formation is that if you observe, I have connected these two nodes, okay, through union function. I have connected A and B nodes. Union, the work of union is to connect any two nodes, okay. So I have connected, by union function I have connected two nodes. Now I need to check whether they are forming cycle or not. How I can check? I can check using find algorithm, or you can say find function. So find will check the parent of A, find will check parent of B. If these two parents are same, for example, let's say these two nodes are having same parent, then it is a condition that there is a cycle, right? So if A and B are returning same parent, if they are returning the same parent, then I will not include that element into my MST, right? And if they are having different parents, then and only I will include that into my MST. I will include that into my MST. I will calculate the cost of my MST. Like this I will do. I hope you got the overall logic of this. Now this is the code, this is the overall concept and approach of the question. Let us talk about the code. Let us try to code this thing. So in the program, first of all, I have imported import java.util.star and my universal class as usual, and in this what I am doing is that I am implementing my graph using adjacency list. Edge list. In the previous programs we have implemented graph using adjacency list. Now for this we need to sort my given whole graph according to the edges, right? So here I'm using adjacency list, so it will become easy to me in order to perform sorting or pairing operations. So here I have created my static class edge and I have implemented comparable edge because I am comparing edges, right? So the edge which is having the least value is going top on my priority queue, is going top on my greedy approach, okay? So that is why I am comparing my edge, and this will perform sorting in ascending order by weight. The element which is having least weight will come on front, will be the first element, okay? Now I am creating a graph, whatever the elements I have tried, and I am creating a graph here, right? Now after this is the main part of the function, union and find. So basically I have created int n is equals to 4, which is basically the total number of nodes of my graph, and in order to calculate for each and every element its parent, I have created a parent array and a rank array. Rank will tell me whether they are having same rank or not. If they are having the same rank, then I will perform union operation. It is rank is used in union and parent is used in find function, okay? So here you can see that I have created a function called as find function, and I am calculating the parent of a particular element. This find function is basically returns the parent of a particular function, and this union function will combine two elements, right? Will form a connection between these two elements. Now let us code our Kruskal's algorithm. So public static void Kruskal MST. In this I will pass my array list of edges comma int v. I will pass these two things, and first of all what I will do is that first of all I will initialize all the parents with its own value. So here in the init function, for all the nodes I am initializing here, this is my init function actually. So initially I am assigning all the parents as the same value. For example, let's say there is a source node, its parent will be -1, right? For another node its parent will be in itself. Initially I am assigning that, and after it I am calculating parent and union, okay? So here what I will do is that in the function I will call init function, and after calling init function I will sort collections dot sort, and I will perform my sorting on my edges, right? And after this here, why it is showing error? Okay, here I need to give in8, okay? Now what I will do is that after performing sorting on my edges, I will create a variable int mst cost, initialize it with 0, int count, is equals to 0. This will keep track how many times I have visited a particular node, and after that I am running a loop int I is equals to 0, and here the condition is that my count should be less than v minus 1. There is a special property in MST, that is whatever the new edges you are creating, that edges should always be less than v minus 1. V is the total number of vertices. Okay, so this is the condition here, I plus plus. Now what I will do is that I will take the neighbors, int e is equals to my graph, which is nothing but edges here, edges dot get ith element. Whatever the element I am having, I will get that. Now you need to remember here that a edge will have source, destination and weight along with it. A single edge will have these three things. Okay, now what I will do is that I will calculate the parent of a particular element. Parent is equals to, let's say that my source node, find, and I will pass my e dot source. Similarly, int parent b, for my second node, int parent b is equals to find and e dot destination, and if for these two nodes, if they are not having a like single parent, the same parent, then and only I will continue my operations. If they are having the same parents, then it is a condition that there exists a cycle, and in that I will not do anything. I will not take them in my MST. So what I will do is that if here, if parent A is not equals to my parent B, if this is the case, then what I will do is that I will combine these two. I will perform union operation for parent A, which is nothing but e dot destination, e dot source and my e dot destination. I will combine these two nodes. Okay, now after that I will calculate MST cost. MST cost plus is equals to my e dot weight, right? And after that I will increment the count value, count plus plus. And finally, after performing all these three things, what I will do is that I will write system.out.print, and I will print final cost of MST is, and I will print my MST cost. Like this I will perform. This is very, you can see that for Prim's algorithm the code is kind of long, whereas when compared to this is just like 4 hours. So let me save and run this. Okay, so in the main function I am calling my Kruskal's MST, and whatever the output this graph is returning me, I am printing the output in the screen, and you can see that I got the output as final cost of MST is 55, which is same as we dry run before. If you see the dry run of ours, you can see that for this the total cost is 55, right? And we got the same output when we run this question. So this is how we will perform Kruskal's and Prim's algorithm. So up to now we have seen different algorithms, different concepts in graph, and we have seen 5 plus or 7 plus at least different algorithms from different concepts. So up to now we have covered almost each and every chapter in graph, and with that being said, I will see you in the next one.